Hi, welcome to my physics tutorial. My name is Reillh and welcome to Reill's tutorial. So today I'm going to be taking you classes on physics for AP students. We're going to be looking at the AP Physics 1 Premium. We're going to be covering up so many topics in this series, but for the first topic, what we'll be covering would be vectors and scalar, because that is the very beginning of the physics. Now, come with me and let's dive in. So now, this is vectors and scalar. What is a vector quantity? What's a vector? What's a scalar? A vector is a quantity that involves the magnitude and direction. A vector has to do with magnitude and direction. But for scalar, it does not have to do with direction. For scalar, you can say I'm moving for 10 miles in 20 minutes, moving for 3 miles in 2 minutes. But for vector, it tells you the direction. Is that it's going north, it's going south, it's going east, and it's going west. So that's how we plan for both vectors and scalars. For clearer explanation, when we have an object person going from this point here, going from point A to point B, the vector helps. This is going from this point. This is one point here. This is a point of direction. Then now scalar just moves from this point and goes down here. That's what scalar does. Just tell you this is 10 miles apart. But now what vector will do now? Its vector will tell you it's going from this direction to this direction. This direction. So this could be called, this now would be called north, because this is the north of a direction. This is north, either northwest, northeast. It all depends on the direction. If it is going down this way, we call it north, south, east. And if it's going the other way, to be south, it's going southwest, and this one will be northwest. But if it's just going in this direction or this direction, so it tells you the direction of where the mouse is driving to. Okay, so let's dive more into this directions of vectors and scalars. Let's dive more into it. Now we have in vectors, there are different ways of calculating vectors. We have cumulative law of addition. You can either add vectors, you can subtract it, you can multiply. But today we're going to look at the addition of vectors. Now, I mentioned earlier that vectors looks at directions of how of directions of motion. So right now, let me look at this direction going from here to here. Is going north, and this is going east. The B is going east. So now to find the sum of the A and B would be when you add from here to here. You add from distance from here to here, and distance from here to here will give us the distance covered between those two parts. And you can also apply it in different sectors. But when you're adding A plus B, the direction of A plus the direction of B will give us the distance from this to this. Don't always forget to also remember the directions. Always remember the directions, because in this kind of direction now we'll call the southeast of the direction. Okay, so that's how to calculate for vectors. So let's keep going further and see what other way of calculating vectors. Now let's look at this example. Vector A and vector B going in this direction. How do we calculate this vector? So here we have A goes this way. We have this A plus B is what we're trying to add. And since the A and B are traveling in this direction, how are we going to solve this? We know A is going this direction and B goes this direction. A goes this direction and B goes this direction. So for us to find the direction of the both path, with the direction of this and this way, from here to here, all the path together, then we add it up. So what we'll have is A plus B. That's how we'll get the sum of the following vector, A plus B. Add them up together, like I mentioned earlier. In as much that it seems as if they are flowing in a circular path. This one starts from here. This is a starting point for A. Then here it stops here. Then it is a starting point for B. Then the distance from here to here would just be to push these two together. And we have it here as A plus B. Okay, I hope this is a little bit clear. I'm looking at other examples in terms of multiplication of scalar quantity. Scalar multiplication. A scalar can be multiplied, a vector can be multiplied by scalar, and the result is vector. So in this case, when we multiply the vector with a scalar, we always get a vector back. This k is a vector and this magnitude of A is a scalar. By the time you multiply these two together, you will get the magnitude of K and A. The same thing too for direction. The same as A. If K is positive, the opposite of A is the same, but if K is negative, A will be the opposite of that factor. That's what that defines. Then now let's look at one of these examples here. Now this is a scalar multiplication. We have A. This tells us from here to here is A. So we want us to sketch out the multiplications based on their values. So if, let's do that now. We have from here to here is, this is A. Then we have, this is samples of A. Then if we want to get for 2A, A will be 2 times of this line. This will be 2A. Then half of A will just be a little bit of this. That will be A. The negative of A will be in the opposite direction. The negative of, negative is similar to A. That's going to be this way. The negative of 3A will be a longer path in 3 directions. So this is negative of 3A. This is negative of A. This is half. And this is 2A. So, does that make any sense? Negative of everything. So that's how it's going to be calculated, and that defines it properly. Move on to the next ones. Vector subtraction. Vectors can be subtracted, but it all depends on the direction of the vectors. So when we have A minus B, if you remember the previous example we had A. When we have, if A is this way and we have A minus B, so that means if A is from here to here, it represents A, then B will be the negative part of A. This will be B, the opposite direction, A minus B. So for these two, let's look at this example. For 2 vectors A and B, find these vectors A, B. So now if we have A, B, if A is going this direction, then since B is negative, B would go what direction? Will go in the opposite direction of A. So this will be A, and this will be negative B, because it's going in the opposite direction of B. Then now when we want to look for the sum of both of it, it will be A minus B. So if A is 7 and B is 5, so A minus B will be 2. Okay, so that's how that is defined. I hope this is clear and it's not so complicated. Always remember, once it's a vector subtraction, the vectors are traveling in different direction. If it's a vector addition, they're traveling in the same direction. in that for more clarification, this is a direction, this is a north, this is a south, this is a east, and this is a west. So if one is going up here and the other one is going this other direction, it's going to be a subtraction. But if it's going here and this one is going here, you're going to add them together. They're going to drive in the same direction. This is what I meant by addition and subtraction. So now we have two-dimensional vectors. In these two-dimensional vectors, it tells us that vectors that lays in the plane